These are the lesson activities for section 1.6 part 1 for Math 117. For each of the scenarios described below, we're supposed to do 3 things. Determine which of the 4 fairness criteria the scenario relates to. 2, determine whether or not the scenario demonstrates a violation of that fairness criterion. And 3, write a summarizing sentence of this form. In this scenario, the blank method satisfies or does not satisfy, violates or does not violate the blank criterion. Okay, so here's an example. In this scenario, the plurality method does not violate the Condorcet criterion. So we have 4 methods to choose from and 4 criterion to choose from for the first and third blanks, and then violates or does not violate in the middle. Okay, so for part A, no candidate gets a majority of the first place votes. So we're talking about the majority criterion, right? Because they're using the word majority. So let's put that in. I think they're talking about the majority criterion. Okay, no one got a majority. Using the plurality method, candidate A wins the election. So let's remember what the majority criterion says. It says that if someone gets a majority, they should win the election. It doesn't say what should happen if no one gets a majority, only that if someone gets a majority, they should win the election. So since it doesn't say anything about what should happen in the case where no one gets a majority, then this does not violate what the majority criterion says. And the method we were using to calculate the winner was plurality. So in this scenario, the plurality method does not violate the majority criterion. Remember, the only way to violate the majority criterion is if somebody gets a majority but loses the election. Okay, part B. Candidate A beats every other candidate in a head-to-head comparison. So that is the definition of a Condorcet candidate. If a candidate can beat every other candidate in a head-to-head comparison, then they are Condorcet. So I think we're talking about the Condorcet criterion, which says that if someone can beat every other candidate in a head-to-head comparison, they should win the election. Okay. But apparently, we used the Boredom method, and candidate A did not win the election. So in this scenario, the Boredom method, which is what we used, violates or does not violate. Well, candidate A beat every other candidate in a head-to-head comparison but lost. That's the only way to violate the Condorcet criterion. If someone can beat every other candidate in a head-to-head comparison, they should win. So this violates the Condorcet criterion. Part C, candidate A wins the election using the plurality method. Then candidate B drops out and the votes are recounted, and candidate A wins the recount. So because candidate B drops out, that is probably the dropout criterion that we are discussing, also known as independent of irrelevant alternatives, or IIA. We'll just call it dropout. Okay, so we are talking about the dropout criterion. Okay, and the dropout criterion, I'll remind you, says that if a candidate wins the election, then another candidate, a non-winning candidate, drops out and the votes are recounted, the original winner should still be the winner. It should be irrelevant that a non-winning candidate dropped out. So because candidate A won and then also won in the recount, this does not violate the dropout criterion, and the method was plurality. Okay, Part D. Candidate A wins the election using pairwise comparisons. Then we have a new election, and everyone votes exactly the same, except some people rank candidate A lower on their ballots. Candidate A does not win the new election. So this is the one with the revote, but nobody drops out. So there's two criterion that use there's a revote. One involves a candidate dropping out and the other one does not. So the other one is called the Monotonicity Criterion. So the Monotonicity Criterion is the one we're trying to analyze here. And the Monotonicity Criterion says that if a candidate wins the election and then we have a revote and every voter ranks candidate A the same or higher on their ballots, candidate A should still win. So this is a little bit different than that scenario because people are ranking candidate A lower on their ballots. Okay, so that of course could lead candidate A to losing the election. So this does not violate. So the pairwise comparisons method does not violate the monotonicity criterion in this example. If that word that I highlighted in green, if that said higher, then we would have a violation, right? But it says lower, so it's not. Part E, candidate A wins the election using plurality with elimination. There is a new election and everyone votes exactly the same, except some people rank candidate A higher on their ballots. Candidate A does not win the new election. This is exactly what the monotonicity criterion says should not happen. So in this one, we have the pairwise, it's a plurality with elimination. The plurality with elimination method violates the monotonicity criterion. Okay, part F. No candidate beat every other candidate in a head-to-head comparison, so there is no Condorcet candidate. Using the plurality with elimination method, candidate A wins the election. So that first sentence, there's no candidate beating every other candidate in a head-to-head comparison. That is something that's discussed in the Condorcet criterion. So that is the one we're examining. We used plurality with elimination, so I'll say the plurality with elimination method. And then we just need to say violates or does not violate. And no candidate was Condorcet. No candidate beat every other candidate in a head-to-head comparison. The Condorcet criterion says that if there is a Condorcet candidate, if there is a candidate who can beat every other candidate head-to-head, then they should win the election. But it doesn't say anything about who should win if there is no candidate who can beat every other candidate in a head-to-head comparison. So this does not violate. Okay, number 2. We have consider the following preference schedule. Does this example illustrate that the plurality method violates the majority criterion? Okay, so let's see, number of voters here. I need to know if anyone has a majority. So I'm going to count up the number of voters. 6 and 5 is 11, and 9 is 20, 22, 25, 28, 31, 36. Okay, which means a majority, more than half, so half is 18, so a majority would be 19. So now I'm going to use the plurality method, count up the first place votes for each candidate. A has 20. B has 5, 8. C has 5, and D has 3. So does this violate the majority criterion? A would be the winner here. A has a majority and 1, so no violation. Okay. The majority criterion says that if some candidate has a majority of the votes, they should win, and that's exactly what happened. Does this example illustrate that the plurality method violates the Condorcet criterion? So Condorcet talks about head-to-head matchups. We have to know, is there a candidate who wins all their head-to-head matchups? So we have to do the matchups. A against B, A against C, A against D. And A is the most likely candidate to be Condorcet. So let's just start with doing these 3. So A is going to have 20 because they have these 20 first place votes. And then B has these 8. Okay, and then B also has these 8 because A is below B in each of those cases. So A has 20, B has 16, A wins that matchup. Okay, let's look at, oops, I didn't mean to erase that. A against C. So A gets the first 20, and then the next column that starts has a 2 at the top, A is ranked above C, so 2 more go to A. And then the 3 has C ranked above this one, this one, this one, this one, and this one. They all have C ranked above A, so that's 3, 6, 9, 11, 14. So that makes A the winner there. And then A against D. A gets the first 20. A is above D. A is above D. So A gets another 5. And then the rest go to D. 3, 6, 8, 11. So A wins that matchup. So A wins all of their head-to-head matchups. They're undefeated against every other candidate. So A is Condorcet. And if we use plurality method, A wins the election. So we do not violate Condorcet here either. A had a majority of the votes. They win using plurality. And so there's no violation of majority criterion. A is the Condorcet candidate, and they win using plurality, so there's no violation of the Condorcet criterion. Okay, so maybe this example will have some violations. Let's see. Does this example illustrate that the plurality method violates the majority criterion? Okay, so we need the total number of voters, which would be 3, 7, 16, 25, 27, 32, 40, 43, 55. Okay, majority would be more than half of 55. So 55 over 2 is 27.5, so a majority would be 28 votes. So let's use the plurality method, like they said, and determine the winner. So A has 3, 7, 16 votes. B has 9, 11, 16 votes. C has 8 and 3 is 11, and D has 12. Okay, so who's the winner? I guess it's a tie between A and B. Did we violate the majority criterion? Well, no one got a majority. So you cannot violate the majority criterion. You can only violate the majority criterion if someone got a majority but lost. Okay, so this is no because no one had a majority. Does this example illustrate that the plurality method violates the Condorcet criterion? Okay, so let's do all of our matchups here. A against B. A gets 16 from the first 3 columns. B gets 16 from the next 3 columns. And then these 3 columns, we have to figure out who's ranked higher. So in the 8 column, B is ranked above A, so we give 8 to B. In the 3 column, A is ranked higher, so A gets 3. And in the 12 column, A is ranked higher, so A gets 12. So A wins that matchup. So A is now a possibility for a Condorcet candidate. B is not. B has now lost a matchup. They're definitely not going to be undefeated. So I'm going to continue with A's matchups to see if A beats everyone. Okay, so A gets 16. And then the next 3 columns that were B's first place columns, we have to decide who we should give those to, A or C. So the 9 has C ranked above A, so we do 9 there. Then the 2 has A ranked higher, and then the 5 has C ranked higher. Okay, then the next 2 columns are C's first place columns, so those go to C, 11. And then the last column has C ranked above A, so we give 12 to C. And that means I have 18 to 20, 32, 37, I think. So C wins that matchup. Which means that A is not Condorcet, right? So A has now lost a matchup. I'm not going to bother doing A against D because I know A is not Condorcet. Okay, but now C is a possibility that could be Condorcet. I should do all of C's matchups. So let's do B against C. So the first 3 columns, the first 2 columns go to B, so that's 7. And then doing B against C. Okay, then first column with a 9 at the top goes to C. The next column goes to B. And then I have, the 9, 2, 5 are all B's columns because they're all B in first place. And then the 8 and the 3 both go to C. And then the 12 column should go to B or C. C is ranked higher, so we're going to give 12 to C. All right, so that is 9 and 11 is 20, and 12 is 32. And then 9 and 7 is 16, and 2 is 18, and 5 is 23. So that goes to C. So C has now won 2 of their matchups. C beat A and C beat B. Let's see if C can beat D, and that might make C Condorcet. Okay, if C beats D, then they're the Condorcet candidate, undefeated. Okay, so C against D. So in this first column, C is ranked above D, so we give 3 to C. Next column, D is ranked higher, so we put the 4 in the D column. Then in the next column, we have C ranked higher in both the 9s and the 2. And then the 5 column, C is ranked higher. The 8 and the 3 column are C's first place columns, so they both go to C. And then the 12 goes to D. So this is 16. C is definitely going to be the winner there. Okay, so C is Condorcet. C is Condorcet. They're undefeated in head-to-head matchups. So did the plurality method violate the Condorcet criterion? So if C is the Condorcet candidate, they're undefeated. The Condorcet criterion says that they should win, but in the plurality method, C was not the winner. It was a tie between A and B. So yes, because C is Condorcet, undefeated, but does not win the plurality method.